Hello and welcome to this video for Chem 20. In this video we're continuing in the bonding unit looking at the difference between polar bonds and polar molecules. So if you remember in the last video we identified what a polar bond was. A polar bond is when two atoms are unequally sharing electrons, and it happens when two atoms that are sharing electrons have different electronegativities. However, what about the molecule? The molecule can also be polar or nonpolar, just like the bonds. Now, just because a molecule has polar bonds doesn't mean it's going to be a polar molecule. It can actually end up being nonpolar. Okay? And the way this works is because we treat the bond dipoles like vectors, and we add them together to see if they cancel or not. To simplify that, all you need to think about is a tug of war. That's essentially what's happening with polar bonds. There's a tug of war and they're being pulled unevenly, okay? But if you have a molecule, let's say you're in a tug of war and you're standing in the middle here in this red spot, this red ball, and you have all polar bonds, they're all pulling outwards, but they're all pulling in opposite directions. They actually cancel, and you have no net change in movement in your position. And that's essentially what can happen in molecules. So if the bond dipoles are equal in strength and opposite in direction, they will cancel with each other, leaving you with what we call a nonpolar molecule. Okay, so let's say you have CO2, carbon bonded to two O's. The bond dipoles are equal in strength because they're both carbon to oxygen bonds. And they're in opposite directions because they're 180 degrees across from each other, as this is a linear shape. So in other words, the canceling will happen as long as it's a symmetrical molecule, and specifically your terminal atoms, the atoms at the end of the molecule, are the same element. Okay? So if your terminal atoms are the same and it's a symmetrical molecule, the symmetrical molecules are linear, trigonal planar, and tetrahedral. Okay? Those three shapes can cancel their bond polarities if all of the terminal atoms are the same, so that they're pulling with equal strength. Bent and pyramidal do not have the ability to cancel because they're not pulling in opposite directions. So here's a bent shape of the water molecule where there's a pull in this direction and a pull in this direction. They're not 180 degrees from each other. There's a lone pair up there that, remember, is bending those bonds down. And so therefore, the overall molecule remains polar. So the question for today to understand is your overall molecule polar or nonpolar? Do the bonds cancel and therefore make a nonpolar molecule, or do they not cancel and leave the molecule polar? Okay, so the rules are, again, if it's tetrahedral, so you have to go back to your shapes. This is why throughout this unit, we've been doing one or two columns at a time, and we're building up from the previous column. So you have to have the previous columns done in order to do the next column, right? So you have to have the shapes done. You have to identify the shapes. So if it's tetrahedral, they will be nonpolar if all the terminal atoms are the same. Okay, so it says if the atoms attached have the same pull. That means, in other words, you have the terminal atoms are the same. Okay, so for example, if I have C bonded to 4 H's, my carbon is my central atom. The shape is determined around my central atom, which is carbon. It's tetrahedral because there's 4 things. And because my terminal atoms are all H's, they all cancel. So this is a nonpolar molecule. Okay, same rule for trigonal planar. If the terminal atoms are the same, they will cancel. Okay, Pyramidal, on the other hand, will be polar, same with bent, as long as the bonds are polar. So you have to be careful. I could have a molecule like NH3, and again, my nitrogen is my central atom. So even though the terminal atoms are the same, they're not all pulling in opposite directions because the lone pair cancels. In trigonoplanar, this is an example of a trigonoplanar molecule. Around our carbon, it's bonded to 1, 2, 3 different atoms. However, because the middle bond is nonpolar, you can think of it as being one whole middle. And so when we're looking at a tug-of-war here, they cancel because they're in opposite directions with equal strength. That's the trigonoplanar. This molecule is trigonoplanar around each carbon. Okay? This molecule is pyramidal around the nitrogen. However, it's, again, because pyramidal, they're not in opposite directions, so they can't cancel. And this molecule, as long as the bonds are polar, the molecule will remain polar. And in fact, the bonds are polar because nitrogen is 3.0 and hydrogen is 2.2. So this molecule is polar. This one up here is nonpolar. An example of a pyramidal that is nonpolar. Nitrogen bonded to 3 bromides. So again, it's pyramidal around my nitrogen. There's 3 bonds and 1 lone pair. However, nitrogen and bromine have the same electronegativities. So if they have the same electronegativities, the bonds are nonpolar. Therefore, the molecule has to be nonpolar. It can't be, the only reason it would be polar is if the bonds are polar and not canceling. These bonds are nonpolar, so the overall molecule is polar. So pyramidal and bent, you have to be careful. You have to make sure there's a difference in electronegativity between the atoms first. And if there is, it'll be polar, no matter if the terminal atoms are the same or not. And linear again, if it has 3 atoms, you treat it just like the tetrahedral shape and the trigonoplanar shape. You look at your central atom. If the terminal atoms are the same element, they cancel, and therefore this is a nonpolar molecule. If you look at your central atom and you have, sorry, that's not correct. And again, it doesn't matter if the bond is single, double, or triple. These are just examples. Well, let's just do this. So this is my central atom. It's bonded to a sulfur and an oxygen. So the 2 terminal atoms are not the same. Therefore, the molecule remains polar because even though they're pulling in opposite directions, they're not pulling with equal strength. So then the molecule remains polar. Okay? So again, to summarize, tetrahedral, trigonoplanar, and linear with 3 atoms will all be nonpolar, 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 as long as all the terminal atoms are the same. If the terminal atoms are different, they are polar. Bent and pyramidal are always polar, and bent, an example of bent is like water. It's polar, okay? Because of the bent angles, they're not pulling in opposite directions, they cannot cancel. Unless the bonds themselves are nonpolar, then the molecule will be nonpolar, like with NBr3. And another example is pH3. pH3, the P's and the H's have the same electronegativities. So it's a nonpolar molecule because the bonds are nonpolar. Okay? If you have no central atom, because your molecule is made up of just 2 atoms, whatever the polarity of the bond will be the polarity of the molecule. So that's what the last thing says here. If there's 2 atoms, whatever the polarity of the bond is the whole molecule, because that's all there is a bond. Okay? So here's a couple of examples. This is drawing the bond dipole diagram. You don't have to draw them, but it's just, again, kind of showing you why they can't cancel. And these are polar. Water's polar, HCl is polar, but C2H2, there are 2 carbons in the middle, which is nonpolar between them, and then the terminal atoms are hydrogen. So this is a big linear molecule, or linear around each carbon. Whenever you have multiple carbons in the center, you can treat them as just one thing, and then check their shape, it would be linear around carbon 1, linear around carbon 2, because they're each bonded to two things. And then because it's linear and they're pulling in opposite directions with equal strength, they cancel, and that makes a nonpolar molecule. Whereas a very similar molecule, two C's again in the middle, but this time terminal atom is I and H. So they're two different terminal atoms. Therefore, they're not pulling in opposite directions with equal strength. So the molecule remains polar. Okay? A few more that you can try if you pause this video, and then I'll put up the answers. Okay, so HF, the bond is polar, so the molecule is polar because they have different electronegativities. N to N have the same electronegativities. The bond is nonpolar, and that's the only thing making up the molecule, so the molecule is nonpolar. CH4, we already did this example earlier, but again, just a reminder, it's tetrahedral around the carbon. All of the terminal atoms are the same, so they cancel, and that leaves us with a nonpolar molecule. Pi3 is pyramidal, and pyramidal is polar as long as there's an electronegativity difference between the phosphorus and the iodine, which there is. They have two different electronegativities, so that molecule is polar. And then C2H6, you have two carbons in the middle, and they're making up tetrahedral shapes around each carbon. So again, you can think of the carbon as one thing, one center, and all of the terminal atoms are the same. So that makes the molecule nonpolar. It's tetrahedral around carbon 1, tetrahedral around carbon 2. Anytime you have multiple carbons in the middle, the only shapes that carbon will ever make is either tetrahedral, trigonal planar, or linear. And those three shapes can always cancel as long as the terminal atoms are the same. So whenever you have carbon compounds in the carbon in the center and everything else around it, all you really need to do is check the terminal atoms. If the terminal atoms are the same, it'll be nonpolar. Okay, and that, I believe, is it for this lesson. Thank you again for watching this video, and if you have any questions, please feel free to email me.